A dog doesn't worry about time. Why would it? Time is just inside our heads. We invented it, right? Well, not really. Sure, there isn't any definitive proof that time exists, and you could make a whole video about whether or not it exists or not. However, in physics, time plays an important role. For a long time, it was thought that our universe consisted of three-dimensional space, and time was just a thing that kept on running in the background. Einstein, however, realized that time is part of space, the fourth dimension. Therefore, we now think our universe as a four-dimensional space-time. A good example of this is GPSs. If you didn't take time as fourth dimensional into account when creating a GPS, it simply wouldn't work. Now, as you know, we can easily travel in the three-dimensional space, just walk from another place to another, but could we also travel in the fourth dimension? Is time travel possible? Let's start with the easy one. Traveling to the future is not only possible, but also pretty easy to do. According to Einstein's general relativity, time passes more slowly when you're close to a massive object. So, all you have to do is find something that's more massive than Earth. A lot more massive, if you want to have noticeable results. A supermassive black hole, for example. Now, how does one travel in time with a black hole? It's quite simple, actually. All you have to do is orbit it. The closer you are, the slower time will run for you. There's a supermassive black hole at the center of every galaxy, including ours. The one at the center of our galaxy has a mass of 4 million suns. A mass that huge has an easily noticeable effect on time. According to Stephen Hawking, orbiting around the black hole at the center of our galaxy would make time slow down to half of Earth's. Orbit it for a minute and 2 minutes have passed on Earth. Orbit it for a decade and 20 years have passed on Earth, and so on. Of course, there are some problems, such as distance. The black hole at the center of our galaxy is 26,000 light years away from Earth. That's a huge distance, exactly 245,978,992,287,100,800 kilometers away. Currently, the fastest man-made object is the Voyager 1, which travels at the speed of 61,300 kilometers per hour. It would take around 458,071,674 years for Voyager to reach the center of our galaxy. In other words, you'd have to spend almost 1 billion years on a spaceship just so you can travel a few years into the future. However, gravity isn't the only thing that makes time go slower. According to Einstein's general relativity, time also passes more slowly the faster you move. As you might have guessed, it requires incredible speed to have noticeable results. The fastest thing in the universe is light. The speed of light in a vacuum of space is about 300,000 kilometers per second. According to Hawking's, if you reach 99% of speed of light, the time would slow down so much that one day at your spaceship is a whole year on Earth. However, we can't reach such speeds. Not even close. So while travelling to the future isn't really worth the effort, it still is very much possible. Travelling to the past, on the other hand, is a whole other story. It's riddled with all kinds of wild theories and paradoxes, the grandfather paradox probably being the most famous one. If you could go to the past and kill your grandfather before he has had any kids, you would never have been born, and therefore you wouldn't be able to go back in time to kill him, which means you are born, and so on. But in order to experience these paradoxes, you have to travel back in time. Unlike with travelling to the future, there is no natural way to travel to the past, but maybe us humans can create something. There are 2 ways to approach this. First, making time run backwards. Go ahead, take a guess if it's possible to do that. Of course, absolutely not. You see, in 1927, a British astronomer called Arthur Eddington came up with the term arrow of time. Arrows of time are basically showing us the direction of time. They explain us why past is past and why we can't remember tomorrow. The first arrow of time was the thermodynamic arrow of time. It shows how entropy and disorder increases over time. The most fundamental arrow of time is believed to be the cosmological arrow of time, since most of the arrows of time can be linked to it. It points in the direction of the universe's expansion. If you wanted to make time run backwards, you'd have to change the direction of time. In other words, you'd have to, for example, reverse the expansion of the universe. That's obviously not going to happen. The universe is huge, quite possibly infinite, and it's expanding faster than the speed of light. Now, some people argue that there is another way to make time run backwards, going faster than the speed of light. But there's two problems with that. One, you can't reach speed of light, and two, you therefore can't go any faster than the speed of light. But what if we just move to the past without making time run backwards? Well, a machine that sends us to the past won't be possible. It would break causality, the cause and effect, in other words. If you press a button now and end up 500 years in the past, the cause, which is you pressing the button, would be in the future, while the effect, which is you ending up in the past, is in the past. You can't have effect before the cause. Some people argue that you could make a tunnel between 2 points in space-time, a wormhole. However, there are plenty of problems with that, such as that they're way too small for a spaceship and they tend to last for a very short period of time. And of course, the fact that we have absolutely no evidence that they even exist in the first place. But let's assume they do exist, and are stable and big enough for you to go through. What would happen to you? Well, you would most likely find yourself in a distant galaxy. Wormholes are shortcuts between long distances rather than time machines. But on the bright side, if you ended up in a galaxy that is, for example, 1 billion light years from our own galaxy, you would see Milky Way the way it was 1 billion years ago. That is because it takes light from the Milky Way 1 billion years to travel to that faraway galaxy. So in a way, it is time traveling. You don't get to live in the past, but at least you get to see it. But, to put it briefly, nothing in the world of physics really supports traveling back in time. And those theories that may do so are far from possible for us to try. That being said, there is still one way you could experience the past, but kind of poor man's time travel. You see, there is a finite amount of particles, and a finite amount of ways you can arrange them in a finite amount of space. Take our observable universe, for example. It is huge, and the amount of particles and the amount of possible arrangements for those particles is insanely high. But it's still finite. Now, start filling the universe with regions the size of our observable universe, and use every single amount and arrangement of particles possible. If the universe is infinite, you'll eventually run out of those regions. You'll have to start over. This is what theoretical physicist Greene calls a quilted multiverse. In an infinite universe, there is an infinite amount of copies of you, planet Earth, or even our observable universe. There are also infinite amount of copies of you with slight changes. There should be a planet Earth where a nuclear war has happened, a planet Earth where dinosaurs still live, a planet Earth where this video doesn't exist. There also could be a planet Earth where the history is the same as ours, but they're still 1,000 years behind us. But why is it called quilted multiverse? Well, because these clones are far beyond our observable universe. Remember how it would take around 450 billion years for Voyager 1 to reach the center of our galaxy, which is 26,000 light years away? Well, the edge of our observable universe is about 41 billion light years away. We will never reach any information, not even light, beyond our observable universe. So you might as well treat the outside regions as different universes. But maybe you could end up in one, with a wormhole one day. In conclusion, we will most likely never travel to the past, and travelling to the future, while possible, is not worth the effort. That's a bummer. But at least you can try and make the present so cool that future generations will be jealous because they'll never experience it. Thanks for watching. Be sure to subscribe to not miss any future videos.